Hello, welcome back. I know it's been a while. Here we have this project that I built in the last video. Something seems a little off about it. I mean, isn't it strange that the scene, which describes all of this data, is being owned by the renderer? It seems like we should separate that. And we'll run into problems if we try to do anything like take input from the user. We'll sort of run into problems with that. So let's go through this. By the way, I was agonizing for so long about how to get rid of this. Turns out if you just drag it, you get rid of it. Okay, so we're going to kind of take this from the top. So I'll go to, actually what I'm going to do as well, models, no, not that. This render scene, I don't really like that name. I'm going to call this a game scene. The reason I can't use scene, as I said in a previous video, is that scene is a reserved word within Swift, so it'll complain. And I'm not very imaginative, so I was trying to come up with other names. It's a game scene. Okay, so back to it. Let's go from the top. We'll go to the project app. And the app is really the thing which should own the model data. In other words, basically the underlying database that we're going to work with. So inside the struct of the app, we're going to make a game scene, and I'm going to make it in a special way so that I can pass it to my other views. And I'm going to do that by declaring it as a state object. Okay, so I have a state object, which is, I guess it doesn't matter if it's private or public because this is top level anyway. Maybe it does matter. Anyway. So what I do is I instantiate this game scene, and it's going to complain in a second because game scene needs to conform to a certain protocol, but that's fine. I'll get to that in a second. And what I'll do is I'll take this state object and I'll pass it to my app view as an environment object. So we have state objects and environment objects. They're almost the same thing. It's just that the state object is the sort of the point of instantiation, like the concrete. And then the environment object is sort of an abstract class. So you can't really instantiate something as an environment object. You sort of take it in. You take it in as an environment object and work with it. Anyway, so I'm going to put in my game scene there. And then I need to look at my game scene. Now it says generic struct, this one, requires that we conform to observable object. Okay, no problem. So what we'll do is we'll go to our game scene and we'll say, yep, you are a game scene and you conform to the observable object protocol. Now, there's one more thing we need to do, and that is for each of these variables, everything that we want our views to be able to see needs to be published. So an observable object publishes its variables, and every time these variables change, that is sort of propagated through, and it's, does that make sense? Anyway, it'll be visible to the things that see it. So we have this, that's fine. I'll just check here. Let's give it a second to check that. Yep, that's all good. So then we are creating, what is it, an app view. So we'll go to the app view. And this seems fine. Okay, but what we will need to do is in the preview, we'll need to sort of forward or put in a default environment object. Well, it depends if you want to use live previews or not. But if we want to use live previews, then we should be passing that in. Okay, So then we'll go to the, content view. Okay, so go to the content view. And in the content view, we have, we're going to create a renderer. And this is where I want to use that, that game scene. So I'm going to declare, okay, content view, you can see this environment object. And what you're going to do is you're going to pass this in to the renderer. It's going to complain, so we'll jump in there and have a look at the renderer. So the renderer is used to owning its own. It's used to owning its own scene. First of all, we'll just change that. And what we'll do here, instead of creating a game scene and working with it, is we will simply take this in as a parameter. Okay, right. So when we create a renderer, we tell it, hey, you are a renderer for this scene. And so we can set this up here, self scene equals scene. We're just capturing a reference to it. Okay, great. Cool. Otherwise, nothing else has to change, including the fact that in the draw function, we tell the scene to update itself. It's actually a pretty nifty way of handling the updates. I was having a look. We can set timers and things, but they're just a little bit too janky for my liking. So I'm happy with that. Okay. Then we go back to the content view, and content view is saying, hey, extra argument in call. No, then it says missing an argument label. Okay, now this is a little bit weird, right? We just have to do that. I don't know why it complains, but yeah, that is fine. And fingers crossed this should be okay. So again, remember, this renderer is now, it's not making its own scene. It is taking the original scene, which is being created here in the app's sort of memory space, in the app's sort of scope, and thrown down to the view. And it is throwing back the message to update the scene, and it's picking those variables which have been updated and published. We see the same thing, and that's really good. Now, there's one more thing I wanted to do in this session, and that was to add a simple gesture. Now, I'll be the first to say I'm not a SwiftUI expert. I'm coming at this from a graphics perspective, so I did have to do a little bit of Googling. But I found, Hacking with Swift is an amazing website. Really, really good. And I found some info on basically using gestures. So let's sort of integrate that. So again, we're making an app view. And then the app view, this is the point where we say, hey, because if we go down one more level, we're at a content view, and the content view is starting to do some kind of janky things in order to wrangle this UI kit sort of class into a SwiftUI class. This is sort of the mess down here. So if we want to do that nice sort of top level view control, like setting a frame, setting things, then I'm going to do that here. And what I'm going to do is here I'm going to add a gesture. I'm just going to add a drag gesture. So again, I'm building this for an iPad, but if we click the screen on the iPad and drag our finger, it will respond to that. So we'll say, okay, add a gesture. And the gesture that we're going to add is a drag gesture. And then we need to say, okay, we'll set the action to be performed on change. And it says here, it expects some sort of action object, which is a function that takes something and then does something with it. So what I'll do is I will replace this. I'll say, okay, I'm going to take the gesture, put it into, I think this is called a closure, I believe. Like I said, I'm not an expert. And what I want to do is I want to take the game scene. I'll just use the class name for now. And I'm going to have a function. In fact, I should probably start writing this function. So, hey, game scene, you can update everything. Also, you can take a message to spin the player. And we'll just do this for now. All right, game scene, spin player, and I'm going to take in an argument which is sort of how much to spin it by, or the offset. So the offset, the amount to spin it by, will be the gestures translation, which is sort of like the delta position. Okay, now it is complaining. One of the reasons that it's complaining is it sort of doesn't know what game scene is. If I go back to the instance name, it says cannot find game scene in scope. And that's fine. Remember I was saying multiple views can sort of view something that's been thrown down to them. So there's no reason that we can't just have the same environment object in both views. Yeah, that error's gone away. No reason we can't do that, because it's in the environment. It can be observed by heaps of views in the sort of view hierarchy. So if we have, like if I want to go ham on this and I want to make like little buttons as well as the main metal view, the main metal render, then those little buttons can view the game scene as well, because it's been passed down. It's in the environment. Anyway, hopefully I'm not just like rehashing really basic stuff. Hopefully it is useful. But anyway, then it says argument passed to call that takes no arguments. Okay, so we'll go back to our render scene and now we'll actually write the function. So we'll take the offset, and the type of this offset is a CG size variable. And what that means is it stands for core graphics, and it's sort of the back when Mac was doing core everything, and it was such a good convention. Why change it? Okay, cannot find type CG size. Well, that's a good reason to change it. And what we need to do is we need to import SwiftUI, and now it should have that. Come on. Good. Okay. So what we'll do is we'll sort of work with this. So we'll say, okay, let our change in theta be, and we'll go with this. So it's a little weird that we're using width instead of like X, but hey, that's fine. It complains, hey, we can't cast CG float to float. Yeah, we can. Just do that, right? I don't know. I don't know why Swift doesn't do that automatically, but hey. Okay, cool. So we've got that. And what we'll do is we'll spin the player around. So we'll get the Eulers, and the theta angle is the rotation around the z-axis. We're taking z as up. So go plus equals. Let me just. I'll do the naive implementation first. Player Eulers, and then the phi is looking up and down. That's the rotation around the x-axis. And then I'll just have a bit of boilerplate code. Just really boring code to check the bounds on that. So just copy paste this from my notes. Okay, so just the usual thing. So we want to keep the Z rotation mod 360, 0 to 360, and looking up and down, This angle is an angle away from the z-axis, so an angle of 0 would be looking directly up. An angle of, oh, this is not good. This should be 179, shouldn't it? Because an angle of 180 would be looking directly down. Okay, I have to change that. So where was I? Okay, so we're just keeping this so that we're never looking directly up or directly down, and we're kind of constrained within that just to keep things simple. And then we update vectors. And I noticed something about this update vectors. This is giving me issues in the ray tracing code, is we also need to normalize them. So here in update vectors, we use spherical coordinates to get our forwards. And we take the cross product, we need to normalize that result. Okay. Oh, we've got an error. That's interesting. Argument passed to call that takes, it's just, that hasn't propagated through yet. So let me just double check this. This is looking okay. Go back to app view, and now it should recognize. There we go. Okay, great. Okay, so let's play this and see what's happening. Okay, so let's try dragging. This is with the mouse pad, clicking on the screen and dragging up and down. So down first. Whoops, up. Uh-oh. So I'm not sure if you could see that. It is working. It's just working really, really quickly. So what we can do is we can just take a multiplier just to sort of slow that down so it's visible. Try it again. Okay, so down. Yep. Up. Yep. Okay. Left. Right. Now, just depending on what you're used to, it might be a little more natural for the z-axis rotation to go the other way. So I'll try that again. Now, if I go left, it's like I'm dragging the cube. So it seems a little, I don't know, a little janky, but simply in terms of yeah, it's actually a lot janky. But simply in terms of having control over a SwiftUI view, that's a good start. Whatever our actual sort of application is, we can tweak that to our liking. I'm just happy that we got the thing working. Anyway, so yeah, in this session, we basically took the same original code and we sort of refactored it, made it a little more modular, made it a little more, I don't know, in Python, they say Pythonic. Is there such a thing as Swiftonic? Swiftastic? Did I just make that up? Who knows? But yeah. Anyway, hope you enjoyed that, and I will see you again soon. Bye.